Hello everyone, we're going to be going over section 4.1 in this video. So we're going to be solving systems of linear equations by graphing. We have four objectives. Our first objective being to decide whether a given ordered pair is a solution of a system. Objective 2, solve linear systems by graphing. Objective 3, solve special systems by graphing. And objective 4, identify special systems without graphing. So a system of linear equations, or a linear system, just another shorter way of saying it, consists of two or more linear equations with the same variables. So our linear equations, remember these means are equations that represent lines. Equations that represent lines don't have to necessarily be in slope-intercept form. We can see them written as in this example, something like 2x plus 3y is equal to 4. This is called standard form. So we can see them written in standard form very often, as well as our slope-intercept form, but our linear system will consist of two of these linear equations and have the same variables. So in this case, in our example here, we have x's and y's. And we also normally write them vertically, so we stack them one on top of the other. So saying that, objective 1, we want to decide whether a given ordered pair is a solution of a system. So a solution of a system of linear equations is an ordered pair that will make both equations true at the same time. A solution of an equation is said to satisfy the equation. So once we find our solution, we can also say, in other words, that the solution satisfies our equation. That being said, if you see that somewhere on a homework or exam, you know what that means. So jumping right in with our first example, we want to determine whether the ordered pair 4, negative 3 is a solution of the system. The system in this case being x plus 4y is equal to negative 8, and 3x plus 2y is equal to 6. So if we want to see whether this ordered pair is a solution, we want to start by plugging in our points into our linear system. Our point is 4, negative 3, which means that x is equal to 4 and y is equal to negative 3. So we're going to plug this value of x and y into our system, and we just want to make sure that they are both solutions. So now we're going to get 4 plus 4 times negative 3 is equal to negative 8. And we're going to have 3 times 4 plus 2 times negative 3 is equal to 6. And now we're going to solve these at the same time. So we can separate our two linear equations in this case. We know that they're stacked vertically, but if we want to solve them, we can write them side by side and just make sure that they're correct. So we can move our lower equation to the side as well. So we write a little and sign. And now we just want to make sure that these statements are correct. So in our first statement, 4 plus 4 times negative 3 is equal to negative 8. 4 times negative 3 is negative 12. And 4 plus negative 12 is going to give us negative 8. So in this case, 4, negative 3 was a solution of our first linear equation. Now we just want to make sure or see if it's a solution of our second linear equation. So labeling these, you can say this was our first linear equation and this was our second linear equation. First, second. So moving on to our second linear equation, 3 times 4 is going to be 12, plus 2 times negative 3 is going to be negative 6. 12 plus negative 6 is just going to be 6, which we say is equal to 6. And this is also correct. So since 4, -3 satisfies both linear equations, then 4, -3 is a solution to our linear system. So our point 4, -3, or our ordered pair 4, -3 is a solution to our linear system, and we write our solution set. Our solution set in this case is just represented by curly braces and our answer inside the curly braces, where our answer is the ordered pair 4, -3, and this is our solution set. So all we did to determine whether the ordered pair was a solution of the system was that we just plugged in the values of x and y that correspond to our ordered pair, and we just made sure that both of our statements were then correct. So that means that our ordered pair is a solution of our linear system. Our next objective, objective 2, we want to solve linear systems now by graphing. The set of all ordered pairs that are solutions of a system is its solution set. We just said in our last problem, our solution set was our ordered pair. To find the solution set of a system of 2 linear equations is to graph the lines on the same axes. So we're graphing our 2 equations on the same plane. So you want to draw out your axes, and you would plot both lines in that case on your graph there. And an intersection point between both lines would be a solution to the equations. So if you plot 2 lines on a plane and they intersect at a certain point, that point is your solution. Thus, the coordinates of any point where the lines intersect give a solution of the system. So in our picture here, we have our one single plane. So we have our y-axis and our x-axis, and we have 2 equations given. We see we have 3x plus 2y is equal to 6, which is indicated by our line here. And then we have x plus 4y is equal to -8, which is indicated by our line here. So this graph shows the solution of a system is 4, -3, just like in our last problem. The solution, or the point of intersection, is always written as an ordered pair. And remember now that our point of intersection is this point here. So this means that 4, -3 is our solution. So we've plotted both of our lines, and we just looked for the place where they intersect. So because 2 different straight lines can only intersect at one point, there can never be more than one solution for such a system. 2 straight lines will only intersect once. So when we have our solution set should only include one ordered pair. Solving a linear system by graphing takes 3 steps. Step 1, we graph each equation of the system on the same coordinate axes. Step 2, we find the coordinates of the point of intersection of the graph if possible, write it as an ordered pair. And step 3, we check that the ordered pair is the solution by substituting it in both of the original equations. If it satisfies both equations, write the solution set. So all right, putting this into practice here. We have example 2. We want to solve the system of equations by graphing both equations on the same axes. So our equations here, we have 2x plus 3y is equal to 4, and 3x minus y is equal to -5. Let's just label our top equation here 1 and our bottom equation 2. So we can work on them separately and knowing the distinction. So in our first equation, we have 2x plus 3y is equal to 4. And in our second, we have 3x minus y is equal to -5. Now we want to plot these lines. And the best way and the easiest way to figure out how to plot these lines is to put them in our slope to intercept form, because that gives us our y-intercept and our slope, so we can plot a second point. So let's rewrite them and solve for y to get our slope-intercept form. So in our first equation, we have 2x plus 3y. We're going to subtract 2x from both sides. We're going to get 4 minus 2x. So now we have 3y is equal to, we're going to rearrange our equation now to say -2x plus 4 instead. Just keeps it more in the slope-intercept form. And now we want to solve for y, so we're going to divide each term by 3. And this gives us our equation y is equal to -2/3 x plus 4/3. So now we have our equation in slope-intercept form. Now we can go on to our second equation that we're dealing with, our 3x minus y equal to -5. So we want to isolate y, so let's just go ahead and subtract 3x from both sides. This gives us 3x minus y minus 3x equals to -5 minus 3x. So now we're going to have -y is equal to -3x minus 5. And we just rearranged our right-hand side there. So since our y is negative, we can just say, well, let's go ahead and let's go ahead and divide each term by -1, which in this case is going to make each term positive. So now we have y is equal to 3x plus 5. So we have our linear system here, and what we've done now is we've rearranged our terms we've rearranged our equations into slope-intercept form. So we have our slope-intercept forms, and we want to make sure that we plot these lines correctly. So let's just write out a table, and let's just give it 3 different values. So we have our x and y table for both cases. We know we can easily find our y-intercept. So our y-intercept being when x is equal to 0 in both cases. So for our first equation, when x is equal to 0, y is going to be 4/3. And let's go to +1 and +2. When x is equal to 1, we have -2/3 plus 4/3, which in that case is just like saying 4/3 minus 2/3, which is just going to leave us 2/3. Then when we plug in 2, we're going to get -2/3 times 2, which gives us a -4/3 plus 4/3, which is equal to 0. So we've now also actually found our x-intercept. So now we have our points for our first equation here. And this is going to be blue. We're going to draw a line in blue. So we have our points. We have 2, 0, 1, and 2/3. And in this case, we're just estimating since we don't have exact values on our graph. So we have 1 and 2/3. Let's say it's about right here. And then we have 0 and 4/3, which is 0 and 1 and 1/3. So once again, we're just going to estimate our graph. And now we can draw our line through our points. And this line here, this was originally our 2x plus 3y is equal to 4. And our second equation is going to be in green. Let's go ahead and fill out our table first. So in our table, we have our x value of 0. So our y-intercept we know is 0, 5, reading that from our slope-intercept form. And now since we went 0, 1, 2 in our last table, we could also go 0, 1, and 2, or we can go down. So we can go 0, -1, -2. If we plug in -1 into our equation, we get 3 times -1 plus 5. So -3 plus 5 is going to give us +2. Then if we plug in -2, we'll have 3 times -2, which is -6, plus 5 is going to give us -1. Now let's go ahead and plot those values. So we have 0, 5. So we have our y-intercept here at the top, and we have -1 and +2. I just realized I did not draw out our last line nearly long enough, so I'm going to draw this much farther, which coincidentally might give you a hint as to what our answer is going to be. So continuing on, plotting our second equation now. And we also had -2, -1. -2, -1. And we see here our line, our points definitely fall in a line here. The line that is technically straight. And this line is y is equal to 3x plus 5. And we see they do intersect. They intersect at the point -1, 2. So since we've shown that they've intersected at -1 and 2, we want to say our solution set is the ordered pair -1 and 2. And if we want to check and make sure that this is correct, we can go ahead and plug in -1, 2 into our system of linear equations, which was 2x plus 3y is equal to 4. And 3x minus y is equal to -5. So we can go ahead and just plug this point just to check and make sure that this is correct. So like we said before, our top equation was number 1 and our bottom equation was number 2. So with our number 1 equation, 2x plus 3y is equal to 4. In our second equation, 3x minus y is equal to -5. We can write them side by side to just make sure that our statements are correct. So plugging in these values, 2 times -1 plus 3 times 2, we say is equal to 4. Well, 2 times -1 is -2, and 3 times 2 is 6. And -2 plus 6 is going to be 4. So we do have 4 equals 4, and -1, 2 is our solution for our first equation. Now we just want to make sure it's also the solution of our second equation. So 3 times -1, we plug in these values. 3 times -1 minus 2 is equal to -5. Well, 3 times -1 is going to be -3 minus 2 is in fact equal to -5. So we have -5 is equal to -5. This is correct, and our solution set is going to be -1, 2. So all right, there was a lot of rewriting, table forming, and checking going on in this case. But we are given our two equations. We just want to rewrite them into our slope-intercept form, which makes it easier for us to actually graph our lines. And then we just want to make sure that that intersection point that we found checks out by plugging it back into our original linear system. So, all right.